So this is probably going to be the shortest section of notes that you get this year. Just going to do the first half of this presentation, which is the idea of center of gravity. Center of gravity is one of my favorite topics to teach because there's almost no math, and there's lots of awesome and kind of counterintuitive demonstrations that we can do with this topic. Anyway, center of gravity is a location on an object where gravity can be said to act. It's basically the point at which we could say this is the center of object. This is where gravity is pulling on the object. And what's interesting about this is we can imagine this place to be the place where all of the matter exists, even though the matter is distributed throughout the substance. Now, one thing that we do in physics frequently is we oversimplify things, and so here we're assuming that the substance is uniformly distributed. So, for example, if I have a meter stick, I'm assuming that the meter stick is consistent, that there's not some area where the wood is a little bit more dense, maybe due to a knot in the original tree that causes that area to be a little bit heavier than the other areas. Instead, we assume the materials to be uniform, and you'll see that used in physics text quite frequently. But when the material is uniform, we can then assume the center of gravity to be the spot where all the matter exists. This is also the point where the object can be balanced. So if you're going to balance an object, you have to have its center of gravity on or above the base of support. And so the center of gravity is the spot where you can balance an object. And it is the same as the center of mass, with the exception, you don't need to jot this exception down, but with the exception of when you have a very large mass and it results in compression. For example, skyscrapers, once they get to be really tall, the center of gravity is slightly higher than the center of mass. The center of mass, because of compression, the bottom ends up being a little bit thicker, and so then the center of mass is a little bit lower than the center of gravity. An object is most stable when its center of gravity is lowest. If you toss an object, its center of gravity will follow a parabolic path when it's in projectile motion. And so we've talked about projectile motion quite a bit already, but the center of gravity will follow projectile motion. One of the interesting things is if you have the object break apart while in flight, say it's a firework or a water balloon or grenade, if it breaks up in the middle of flying, the pieces will still follow the parabolic path, although as they spread out due to the law of conservation of momentum, you end up having the center of gravity follow the parabolic path even if the pieces are beginning to spread out. An object is balanced when the center of gravity is above the base of support, which I kind of mentioned already, otherwise it will topple over. Be sure if you have any questions that you bring them to class.